Welcome. In this lesson, we're going to use Pythagorean's theorem in order to find missing links in word problems. The biggest recommendation I have for you to help you do these word problems is always to draw a figure or a diagram. So let's read the problem. A gopher has dug a hole in opposite corners of a rectangular yard. So my diagram is going to look like this. And I have a gopher hole in one corner and a gopher hole in the other corner. It says one length of the yard is 6 meters. So I don't care which side I make 6, I'm just going to make one side 6 meters. And then it says the distance between the gopher holes. So the distance that goes between the two holes is going to be 10 meters. Now what we need to do is it says, how wide is the yard? So we need to find this length right here. Now, if this is a rectangular garden, those are right angles. So I have a right triangle where I know the hypotenuse's length is 10, and I know the one leg of the hypotenuse is 6. So I use Pythagorean's theorem. I'm going to square 6 squared, because that's one of the smaller sides. I'm going to add that to, now I'm going to use for a second the a squared plus b squared plus c squared. But again, just realize we're going to end up subtracting because we know c and a and not b. So I don't know b squared equals, because I'm making this a b, this is a, and this is my c, equals 10 squared, which means the larger square would be 100. The smaller, one of the smaller squares is 36, and I'm trying to find the last square's length. So minus off the 36, I find out that the b squared, or that other square, is 64 in measurement, or 64 units squared. I square root it to find the value of b, and I find out that the b, or width of the yard, is going to be 8 meters. Because 10 squared is 100, 6 squared is 36, 100 minus 36 is 64, and the square root of 64 is 8. So it's 8. So again, draw a diagram, and that should help quite a bit. Okay, so again, a rectangular piece of fabric. So we have a rectangular piece of fabric, and it says a rectangular piece of fabric and makes a diagonal cut from one corner to the opposite. So we're going to cut it from one corner to the opposite, a diagonal cut. The cut she makes is 20 inches long. So I know the diagonal is 20. That's the hypotenuse, because here's a right angle and here's a right angle in our rectangle. Then it says, and the width of the fabric is 16. So I know that one of those lengths is 16. What is this length here from there to there? Well, the larger side, or the larger square, is 20 squared, which I believe is 400. That's 20 squared. I'm going to minus off one of the smaller squares, which is 16 squared. By the way, I don't know what 16 squared is, so I'm using my calculator. 16 times 6 is 256. And that's going to equal this smaller square over here. And then I just find the length of the square to find the length of the, or the width of the rectangular fabric. So 400 minus 256 is going to be 4. That's 9 minus 5 is 4. 3 minus 2 is, oh, it's 144. And I know what the square root of 144 is. It's 12. So the width of the fabric is 12 units. Now, I'm hoping all of you know your north, south, east, and west, because I'll bet anything there will be some problems that involve north, south, east, west. This one does not. So, but it does involve a telephone pole. So first of all, how many of you see telephone poles that are slanted? I'm not saying there isn't some out there, but for the most part, telephone poles are straight up and down. And a pigeon was sitting 12 meters from the base of the telephone pole. So out from the base of the telephone pole, 12 meters, is this bird sitting right here. Okay, and the telephone pole is at a right angle to the ground. and then flew 15 meters to reach the top of the pole. So he flew like this all the way up to the top of the pole. They're assuming the bird flew perfectly straight. The question is how tall is this pole? Well, we have a right triangle. We know the hypotenuse. We know a leg. 12 squared is 144 because that's the area of the bigger square. Minusing off the area of the smaller square down here. What did I do wrong? Oh, one's 15. That's what I did wrong. I accidentally said he flew 12 meters. That's a 15. So that should be 225. That's the bigger square, minus off the smaller square, and then that's going to equal, what is 225 minus 144? Of all things, nope, it's not that. 225 minus 144, it's 81. And so the area of the square over here would be 81. How do I find the length of the square? Well, I square root 81 to find its length, and I find out that the height of the pole is 9 feet. 9 feet. I hope these word problems aren't too difficult for you. You just got to walk through them. Oh, here's the one. Yep, I knew we would eventually get one that has a north, south, east, and west. North and so forth. So Bernie bicycles 3 kilometers west. So again, that's north, east, west, south. So he bikes 3 kilometers west in that direction from his house. So this is Bernie's house. I'm going to put a B for Bernie. To the school, I'm going to put an S for the school. After school, he bikes 4 kilometers north. So again, he turns and goes north. And west and north are at right angles. So he goes north to his friend's house. 4 kilometers. 4 kilometers. Then it's asking how far away is Bernie's house from Rebecca's house. Well, that's a right triangle where one side is 3, one side is 4. We're going to square them and add them together because those are the legs. So 3 squared is 9, 4 squared is 16. I add those together and get 25, and that would be equal to the diagonal or the slant distance from their houses, which would be, again, c squared or 5 kilometers. Again, the biggest issue with these is just being able to write them down, making sure you watch your right angle. Find your right angle in the figure. Find the two sides you know. If they happen to be the legs, square them and add them together, and then square root. But if one of the lengths you know happens to be the hypotenuse, or the side that does not form the right angle, then square the bigger one, minus off this smaller one squared, and then take that new number and square root it to find the length of the other side.